Yeah, yeah. Let me start from the scratch actually. Today our topic for discussion is going to be a streams. Okay, what streams does it? Before we understand what do you mean by a stream, we need to understand what do you mean by a change data capture. Okay, for that let us take one table. I am going to name the table as a table A. So you have one table, and on this table regularly we will do certain inserts. Okay. So if you have any data present in that particular table, on the records in that particular table, we are going to update the records. Then we are going to do the update operations. Then similarly, we as per our requirement, we are going to delete certain rows. So we are going to perform all these operations: insert, update, delete. On occasionally, we may perform truncate operation as well. Truncate means deleting all the data present in a table and keeping the structure as is. Okay. So all these operations, if you are going to perform any of these operations, then there will be a change in the data on this particular table. What stream does is stream is going to capture all the changes that had happened on a particular table. It could be it could be any table. We are going to name it as a source table. Okay. So stream, what stream does is it is going to capture all the data that got changed on a particular table will be taken care by streams. Okay. Let us see practically what is the importance of stream, why we need to capture the changes on a particular table. Okay. So that first initially I'm going to create one database with the name institute. Now I created one type of one database, and I'm going to create one schema known as a courses. So now I'm going to create a table. I'm going to consider this table as a source table. I'm going to create one table with the name students, and I have two, I mean to say I have two columns, first name and subject as a two columns in this particular table students. Okay, let me insert all these records. So now all my
like
records. Yeah. Yes,
like
please.
you write too many SQL queries, right? We can write this one values at a time, right? One
Yeah,
time.
you can write what a time. Actually, you can use the comma instead of like that. I thought actually it would be better for you to understand. So I'll break the statements into
Okay,
single
okay,
individual statements. Yeah. I don't want to
okay.
overcomplicate as everyone is new to this snow.
Yeah.
Now all my records got inserted into Snowflake. Okay, Snowflake table with the name students. Okay. So now let us create one stream. Okay, create or replace stream. And now this is the syntax for creating the stream. Create or replace. What is the as similar to table? Instead of table, here we are going to use the stream as a keyword, and then I'm going to name the stream. Stream name. I'm providing the stream name as a student underscore stream. On which table we are going to capture the all changes? Actually, this is the students table. On this table, I want to capture all the changes which are taking place in a particular this table. Okay. Let me create this stream. So if you query the stream, currently it doesn't have any objects, any records. Why? Because we have after creation of table and inserting data, we haven't created any, we haven't performed any DML operations like insert, delete, update. Okay. So let me try to insert two records into Snowflake. Two records into student table. My two records got inserted with the name Pratap and Bharat. Pratap and Bharat record 7 and 8 got inserted. So let us try to query the stream. What happens? What are the why? What happens when we query the stream? Means this is the stream object that we have created on students table. Now I am going to query this stream. If you query here, if you can notice, these are the three columns that Snowflake got inserted into. These are the two columns that we have created. That students table consists of two columns. But whereas if you query the stream, The stream had added additionally three different columns. One is a metadata action, metadata is update, metadata row ID. Okay, we need to understand these three columns as a part of understanding stream. What stream does is, stream, whenever you create a stream, it is going to add three additional columns for the table on which you have created a stream. Those three additional columns is going to be, one is metadata action, metadata is update, metadata row ID. Okay, so coming to metadata row ID, what it does means, for every row in your Snowflake, it is going to add one ID, which is known as a row ID. It is identical for every row. It is, I mean to say, it is unique for every row. If you have 1 billion rows, you have 1 billion row IDs. Okay, so if you are going to perform same action twice, so let us see in practical how it will happens. So let's remember, as of now, for every row ID, one row ID is going to get created, and it is going to be unique across your table. Okay, so, and one more thing is, what is the action that you have performed on this particular record? Whether are you going to insert a new record, are you going to update a record, are you going to delete a record? These are the actions we are performing, right? Insert, update, and delete. So metadata action, what it does is, it is going to record what is the action that you are going to perform. If you are going to perform insert operation, then metadata action will record it as a insert. If you are going to perform update action, then it is going to record as a update. If you are going to if you are going to delete any particular record, then metadata action is going to be a delete. Metadata is update only becomes true when you perform an update action. So let us see. So this is how the columns look like when you perform a insert. So when you perform an insert, metadata action is going to be a insert, value is going to be insert, metadata is update is going to be a false. Okay, similarly, let us do a delete. Okay, here I am trying to do delete. And now let's query from the stream. See, if you notice here, we have performed the delete operation on a first name Raviteja. If you can see, this is the record that we are performing a delete operation. So metadata, what is the action that we have taken? We have deleted the record. So it is not an update. So is update is going to be false in case of insert, and as well as a delete, is update is going to be a false. So now let's update two records, and let us see how our metadata fields is going to act. Now we have updated two rows with the name Megu and Vinod. Let us query from the string. In case of update, if you notice metadata is update, it is going to be a true. Whether if it is going to be is update record, it is going to be true. And if you see here, Raviteja and Vinod and Megu is the two records that we have got updated, row 5 and 6. So metadata is update is going to be a true. So what it is doing, if you notice on the row ID, the actions that we are going to, initially it is going to delete this record with the name Vinod. Here we need to insert as a SF. So earlier it has a Vinod, they have Azure. So it is going to delete the Azure, and it is going to, this is the action. First initially it is going to delete the action, delete the record, and then if you can see here, then it is going to insert the record with the subject SF. So whenever you perform update operation, you are going to get two rows. One is for the delete and one is for the insert. Whereas if you perform only insert, you are going to get only one single metadata row, and similar to delete. Hope everyone is able to understand these three columns: metadata action, metadata is update, metadata row ID. In entire stream, you may discuss 100 examples for the streams. These are the three columns you need to understand. What happens when you insert a record? What happens when, I mean to say, how the metadata is taking care, how it is going to record? What happens when you insert a data? What happens when you delete a data? What happens when you update a data? So when you insert any record, you have one metadata row. When you delete a record, you have one metadata row. Whereas when you update any row, you are going to get two metadata rows. One is to delete the record and insert as per the requirement. Okay, so this is how the metadata action takes place. Hope everyone is able to understand the concept of streams, where we are going to capture the change data. Whatever the records that is getting changed in the table, stream is going to capture all those changes. Okay, hope everyone is able to understand these. We have a two types of streams. Okay, let's go and discuss that. We have a streams is of actually three types, but majorly we will discuss only two which are important. Have a three different types of streams. One is a standard streams. One is another is append only stream. Then insert only. Insert only streams only will be happened in case of external tables. External tables only whenever we are going to use external tables, then we are going to utilize the insert streams. So for current agenda, we are going to discuss about the standard and append only streams. For the standard streams, whatever the changes that you are going to make, all the DML operational changes could be insert, update, delete, and truncate. All these DML operation changes is going to get recorded in the standard streams. Whereas in the append only streams, it is going to take care only in case of insert operations. If there is any new inserts happening, it is going to track that. It doesn't bother about what are the updates happening, what is the deletes happening. Okay. Usually we never use append streams in case of in reality we never use append streams. There could be very few very minor examples where you may use the append only streams, but in general every real-time project uses the standard stream. Okay, so let us see how the append only stream works, how it is going to capture only the insert records and it doesn't capture any update or delete record changes. Okay, let us see example for the append only stream as well. So same here I am trying to create one new database with the name institute. Similarly, I am going to create one table. Initially, I am not creating any streams. Just I'm inserting the records into this particular table. Now, if you are going to query this table, you have the 6 records. So, if you want to create append only means, then you are going to provide an additional parameter known as a append only. Append only is the parameter that you are going to provide to create the stream, create or replace stream. We are going to use the stream name on the table which you are going to create the stream. Then you are going to give append only equal to true. It means that it only track and capture only the changes that happens only the inserts. It captures only the new inserts and ignores all the deletes and as well as the update operations. Okay, let us create this stream. If you query the stream, currently we haven't performed any new inserts. Our stream doesn't contain any data. So let's insert new 2 records and execute the stream object and query the stream object. So the stream object successfully captured the new inserts. These are the two new records which we inserted in our table. These 2 records got successfully captured by the stream. Let us see if the append only stream captures any changes that was performed using the update and delete. Okay, now I am deleting one record with the first name Raviteja. Now if I query from the stream, it haven't captured any metadata for the delete operation. Why? Because it's a append only stream. Append only stream take care of only insert new records which are getting inserted and ignores all the updates and deletes. So in our case, it haven't captured the delete action that we have performed on a record. Now let us try to update 2 records and let's see how our stream is going to, whether the stream is going to capture the records or not. Here I have updated 2 records. And now let's query from the stream. So even the update haven't captured any update changes haven't captured by our stream. That is, it is going to be a only append only stream. Let us insert new records, two new records again. And now let's query the stream object. So it must get captured with the stream and it is the insert. If you notice here the new records which we are trying to insert, Uday and Satish had captured by the stream. Why? Because it is going to be a insert. So we have a two different types of streams. One is a standard stream which captures all the changes that are happening in a table. Either it could be insert, update, delete. And another stream which is known as an append only stream, which captures only inserts. It doesn't bother about the updates and deletes. It is going to capture all the inserts only. In real time, we may never use append only stream. We will use the stream known as a standard stream to capture all the DML operations. Okay. Hope everyone is able to follow and understand this streams concept. Any doubts so far? Yep. If there is no doubts, let's move on to the next topic. So we have captured the changes. How we are going to consume the changes? Okay. So let us see why we need to consume we need to understand why we need to consume the stream actually. So that you need to understand we have a table A here and table B. We have a table A and table B. So when you perform initial load, successfully you load data. Let us consider you loaded around 10 lakhs records. So this is going to be considered it as this is our stage table. This is our reporting table, which we are going to share data to the downstream. This is the stage table where we are going to receive the file, and once the file get received, all the data will be loaded into this particular table. Okay. In the initial state, let us consider that we have loaded the 10 lakhs records into a table B, and now all the data that was present in the table A contains the table B. This is the day one operation. Let us consider in the day two, you receive in the 10, you have received 10 lakhs, around 10 lakhs and 30 records. So among these, 30 are going to be a new records, and already the previous records which were present got updated by 23 records got updated. So in this scenario, if you notice, it's not feasible to drop entire, it's not a good idea to drop entire table B and drop and load again the table A. Instead of that, if you want to load only the 30 new records which were arrived and take care of 23 records which got updated, then in such scenario, we are going to use the concept known as a streams. We are going to apply the stream on table A. Then we are going to identify what are the changes that had happened in the table A, and we'll fetch the details. What are the changes that had happened into table B, and then in the on table B, we are going to insert only the new records which got updated into table A, and the updated records which got changed, we are going to modify the records in table B. This is how we are going to deal with the streams in real time. Okay, we are going to, so instead of truncating entire table and loading the data again, we are going to apply the concept streams, and whatever the new records that updated on a stream source object, we are going to fetch the data and load only the new inserted records again, and alter or modify the updated records or deleted records. Okay, let us see practically how we are going to capture all the changes and how we are going to consume the stream object. Okay, for that we require the knowledge known as a knowledge on the SQL using the merge command. This can be achieved, usually this can be achieved on every, and usually we will write the merge command in general, or else we'll write the stored procedure, but majority of the people will try to use the merge command only. we need to have a little knowledge on the merge command. If you don't have any knowledge on merge command, do not worry as of now. We will discuss the merge in later point of time. Okay. Now let's go to the, so let us consume the stream object. Further, so I have successfully created one database. Now let's create one schema. Now what I am trying to do is I am going to create a source table and a target table, destination table. As in our class, we are discussing about the table A and table B, right? Similarly, we are going to create the two tables, which is a source. So I am considering and creating the students table as a source table. Let me execute this. Now I have successfully created my source table. Now let's create our destination table. So now I have created successfully my destination table. Source table was ready and the target table was ready. So I am going to create stream on the source object, source table, and I am going to identify what are the changes happening in this source, and I will try to load the any new inserts into a source will be loaded into destination table. How we are going to load? Let's see. So initially, if you query the source table, we don't have any records. Similarly, if you query the stream object, so sorry, we haven't created the stream object as of now. Let us create the stream. So now let's query from the stream object. Now let us query from the destination table as well. So if you notice here, just what we have done is we have created one source table, one destination table, one stream object on this particular students table as a source table. We haven't done anything, and every table is empty. I mean, stream object is empty, source is empty, and our destination table is empty. Now I will insert few records into our students table, source table. As actually I have created the stream object and a source, the new records that got inserted into source table must be captured by the stream object. Okay, let us see it. So now I have successfully inserted 6 records into stream object. Now let's query our source table. So on our source table, we have 6 records present successfully. Now let's query the stream object. The stream object must be successfully captured the new inserts taken place on our source table, as we have created the stream on this particular source table. Okay. Let us query from the source object. Sorry, stream object. Sorry, it's a destination table. The stream is student stream. If you notice here, it had captured all the changes. It say all the inserts, all the 6 records are going to be inserts. It had captured all the changes. Okay. Now our objective is to consume. We want to align the source table and destination table as same, but the changes that had happened in the source table is captured by our stream. So we need to capture the records in the stream object, and we need to update our destination table. Further, we can write the merge logic, or you can call the stored procedure. Now I am using the merge command. Do not worry if the syntax make you a little worry now. Just try to understand the concept of streams as of now. This is the merge command that I have written to fetch the data. This is the merge. What I am trying to do is merge into student destination. Destination is our target table. What I am trying to do is but I want to merge all the records into my destination table, whatever the records that got fetched from the stream object. So using what I'm using the data from the select start from student streams. What is the student stream object here means? Student stream is a stream object that I have created on a source table. I'm trying to fetch entire data which is present in a stream. So based on that, I'm going to fetch entire data. Based on the logic, we have a three records, right? Three additional columns which got added in a stream object. One is going to be a metadata action, metadata is object. One is going to be a metadata insert, sorry, metadata is update, metadata action, metadata row. So we will utilize metadata action and metadata is update. These two records, whenever we notice any new insert, we are going to insert it. Whenever if you notice any delete operation, we are going to delete the record, then we are going to insert it. Okay, let me execute this merge logic. If you notice the what happens in the destination table. So if you are not able to understand this merge logic, do not worry. We will take a separate session on a merge. Actually, this is the important concept. Merge is going to be important logic that you need to understand. Okay, let me execute this merge logic. So if you notice, number of rows inserted is going to be 6. Now let us query from the destination table. Our 6 records got inserted successfully into destination table. And now let's see what happens the data in the stream object. Once the data get loaded into the destination table, what is the situation that is what is the I mean to say what is the situation of records present in the stream object? Let us query it. If you query the stream now it contains 0. Why? Because the data which is present in the stream, it got already consumed. So once the data got consumed from the stream object, the data will be removed from the stream. Hope everyone is able to understand. A part of this merge logic, hope everyone is able to understand the stream concept. So we are going to identify the changes. We have identified the new inserts in the source table, and it got captured from the stream object, and using the merge logic, we are going to fetch all the details from the stream, and we are going to load the data into destination table. Okay, now let's see what happens in case of inserts and updates. Now here I am going to insert two new records. My two records got inserted. If you so earlier 6 plus 2, now students records have 8 records. As my stream object doesn't have any record, as we consumed the previous set of changes, right? The stream object must contain only two records regarding the inserts. It successfully contains the two insert commands here. Now if you try to paste the details from the student destination, only it will contain 6 records. Why? Because we haven't executed the merge command after after the changes have taken place. So now let us execute the merge command. My two new records which got inserted on the source object got inserted successfully into the destination table. Now let us query this. Source must have 8 records, and our stream must not contain any records as we got as the data present in the stream got consumed. Now our stream had produced no results. If you query from the destination table now the source and destination will be in sync, and the source and destination will have a same number of records. Okay, this is how it happens in case of inserts. Let us see how it is going to take care with the delete operations. Now I am going to delete one record with the id 5. From the source object I got deleted. I got deleted from the source, but it will be present in the destination table, and you haven't implemented the merge and change data capture was not implemented as of now. If you see, the record 5 is still present in the destination table, but the changes that was taken place on the source table will be present on my stream object. Okay, now let us execute this merge command. So number of rows deleted 1. So I have executed successfully merge command. So our data in the destination table will be in sync with the source table. If you notice here, the record 5 got deleted from the destination table as well, and the stream object will not contain any data as we have consumed the data that is present in the stream. Okay, this is how the delete operation works, as similar to the update. If you are going to update the records, now I am going to update the 2 records. Now my stream object will contain the data which contains the records that we got updated. 2 records we got updated, right? Those changes will be captured by our stream object. And now if you perform the merge, now the data will be synced with source and destination. Okay, our stream object must not contain any kind of data as we have consumed. Now our stream, source and target will be in sync. Okay, so one thing what we are trying to do is here, whenever we notice a changes, so whenever we notice any kind of change, then we are intentionally, manually, we are going to execute the merge command. So is there any way that we can automatically the merge command triggers on based on any schedules means? Then we are going to use the concept known as a task, which we discussed yesterday. We are going to combine both the task and streams. We are going to implement all this merge logic in a task. Okay, let me show you how we are going to do that. So in this particular scenario, I am going to create one particular task. In this task, I am going to write the merge logic. Yesterday we have written only insert, right? Instead of insert, I am going to write entire merge logic in case of after as. Okay, and I am going to schedule it for every 1 minute. So whenever, I mean to say, this task automatically runs for every 1 minute, and it is going to record all the changes that had happened in the metadata fields, and it is going to perform all the changes based on the changes that we perform on the source table. Okay, let us see practically how this will work. Okay, so for that I am going to create one new database and schema. Now I am going to create the stream object. Good. If you are going to query this, we don't have any records actually in the source table, destination table, and stream object. I'm going to create one warehouse to utilize from the task. So now what I'm trying to do is I'm going to create a task which contains my merge logic. This merge logic will be executed for every 1 minute. So whenever, for after every 1 minute, if there is any changes in the stream object, the details will be fetched and automatically it will be loaded in the destination table. So I'm going to create one task with a merge logic. Initially the task will be suspended, right? Now I am going to resume this task. Now I am going to insert the 6 new records into source table. Manually I am not going to execute any kind of merge logic now. Automatically my task need to execute my merge logic after 1 minute. Let us validate that after 1 minute or 2 minutes. So our stream object must capture all the changes performed on the source table. These are the changes that got captured on the source table. So let us wait for a couple of minutes and then let us validate the destination whether my task executed successfully or not after 1 minute schedule. Okay, any doubts so far? Hope everyone is able to follow me regarding this streams. I mean to say, what are the different types of streams and what is the main purpose of using the stream. Just you need to understand the main purpose of utilizing and using the stream is to capture and identify the changes that are going to perform on a source table. Okay, once we are going to capture all the changes on a source table using the stream, and then the changes is going to consume. We are going to schedule the stream using the task, and then we are going to consume the data present in the stream and load the data into our destination tables. This is what happens in the real time. In every project there will be lot of streams and a lot of tables. Let us give some, yeah. If you notice here on the source student's destination, my task got executed successfully after 1 minute and the data got loaded into destination table. Okay. This is how, if you perform any new inserts, if you perform any deletes, any updates, automatically our schedule executes for our task executes for every 1 minute, and that it is going to record all the changes and it will modify the destination table. Okay. This is how we are going to work with the streams in real time, and we are going to combine the streams with tasks. Any doubts here? Other than merge logic, any doubts? Please let me know. So I will discuss this merge logic day after tomorrow, or tomorrow I will discuss the sequence and types of caches in Snowflake. Then we will discuss this merge command. Hope everyone is able to understand. If you don't understand anything, please let me know, or else you can ping me on WhatsApp or something. I will explain you where you haven't understood. Okay. Thank you guys. Thank you all. I'm wrapping this session for today. Have a good day ahead. Thank you.